All right, you guys, we're just going to jump right in because we have a lot to go over today. Hello, everybody. Welcome to the fourth and final module of the Fiber Hemp Production short course. Today, we're going to be talking about processing and end uses. I am Laura Sullivan, and it happens to be St. Patrick's Day. So happy St. Patrick's Day to everyone. I have my Irish flag hemp right here with me, and it'll stay with me through the duration of the class. And yep, here are previous modules. We have some great guests today. Would like to thank our funders, the USDA, for putting this on for all of us. And let's get started. Here is our beloved agenda. We'll start today's class with a recap, followed by our poll. Then we're going to get into primary processing and technology, old and new. After that, we'll talk about our journey to make the first all local and commercially produced hemp garments in the Northeast. I happen to be wearing one right now. And oops, we will finish with a discussion between Tim Holt of Bat and Kill Fibers and Cyrus Brooks of Muriels of Vermont, who will hopefully both be joining us for a live Q&A at the end, and they were our partners on our sweater vest project. And here is our recap from last week. Last week, we were talking about harvesting and retting. So you're going to want to schedule a sampling event with your sampling agent within 30 days of your scheduled harvest. Male and female hemp flowers mature at different times, with male flowers expressing earlier. Harvest timing will depend on end use. Hemp can be harvested anywhere between 60 days in the ground and up to nearly a year later, the following spring. Harvest method will also depend on end use. Hemp-specific harvesting equipment is not currently widely available in the Northeast. The goal of retting is to dissolve the natural glues that bind bast to hurd in order to make their separation possible. There are several different types of retting. There's field, also known as dew retting, water, also known as tank retting, winter retting, and chemical retting. Field retting will commence as soon as the plants are cut and laid on the ground. Winter retting uses the mechanical action of freezing and thawing to mechanically separate bast from hurd, and most all end uses will require retting to separate bast from hurd. And here is our poll. We have not learned this yet. What are the 3 steps of primary fiber hemp processing? So these are the steps after retting, drying, and storing that take whole stalks and separate them into bast and hurd raw materials. Is it breaking, scouring, and pin drafting, breaking, scutching, and hackling, breaking, mangling, and beetling, or breaking, decorticating, and threshing? And I'll just give you guys 10 seconds there. Okay, so the answer is indeed breaking, scutching, and hackling, and we are about to learn all about it. Okay, so now we're going to get into primary processing. After fiber has been retted and dried, it is ready to be stored or processed. So once your fiber is under 15% moisture, you are able to bale it. It will continue to dry down to 10% moisture during that time. Some people, myself included, believe that the fiber quality gets better if it has some time to rest and sit in storage between harvest and processing. It is an organic material, after all, with a shelf life, so it is going to continue to transform and change basically at all times. No matter when you decide to do it, eventually you're going to want to process your hemp. The 3 steps of primary processing are breaking, scutching, and hackling. These steps take the material from whole retted stalk to separated hurd, line, and tow fiber. These are also the steps that prepare the fiber for spinning. And collectively, these steps could be referred to as scutching, as these are the activities that go on inside a scutching mill. And one more thing is, it's really important that your scutching facility be dry and that your material be bone dry before you engage in primary processing. You will know if it's not because the process will be much more difficult. The traditional way to dry material for processing was to stick the material in the chimney of the house, which I am not recommending anyone do. But now we're going to watch a little video to learn more.
Hello, my name is Laura Sullivan. I work for UVM Extension. Today we are at the Borderview Research Farm in Alburgh, Vermont, and we are processing some winter-retted hemp fiber into sliver. We're gonna go pick some of the fiber out back from the field before it all gets reset for next season. We'll bring it back here. First we'll crunch it up on the break to separate the bass and the herd. After that, it will be scutched with the scutching sword to just remove further debris. And lastly, it will be hackled on this fine bed of nails and combed before spinning.
Okay, you guys, we're just going to pause here for 1 second because earlier on in the class, we learned this word lodging, and this is what lodging means. It's when the plants fall over. For us, this hasn't been a major issue in season, but I have heard of it happening to folks whose fields are too rich with nitrogen. But that's not what has happened here. This is just the result of being out in the elements of winter. And if you remember, Maciek said, he's the one who does winter retting in Poland, said that lodging of winter retted fiber has not necessarily been a problem for him in the past, just because it's his process to just come through and rake the material up. So, and there's no need to even cut it. So if it's laying on the ground, that's not a huge problem. However, it would be a problem if it sat for too long while it warmed up and the stalks in direct contact with the ground started the field retting process over again. So I just wanted to show you all what lodging is.
All right, so the first step of hand processing here is breaking. This is a flax break. It's probably like 100 years old, and I got it off Front Porch Forum. It was living in a historical museum in New York, and then I found it in Jeffersonville, just like on the other hillside to me. And this is the fiber that we just took from out back. It's been winter retted, so you can see some of the fibers already coming off. And the break's just gonna allow us to fully separate the bast, which is this stringy outer like bark layer, from the herd, which is the woody middle part. So now we have hurd, which is basically ready to be used as mulch. Hurd and bast are kind of like a byproduct of one another. So there's a value-added product right there on the floor. This is called a scutching sword or a scutching knife, and it's just like a hardwood sword. And the purpose is just to further remove the remaining hurd debris or any other debris that's attached to the fibers and kind of soften them too. And surprisingly, it's pretty effective because you can see now there's like no more hurd attached to this. And that's something that basically a mechanical device has like yet to perfect, is just clean bast fiber. So all three of these steps combined would be called like scutching together. Like if there was a mill for them, it'd be called a scutching mill. And this process is rounded out with hackling. And hackling is just going to comb the fibers and open them up a little bit and kind of orient them all of the same way. It's also a good way to separate them by length, because as you're working and processing the fiber, they'll separate themselves out based on how long they are. And the wool equivalent, so the wool fiber equivalent to the step would be like carding. This is my hackle that I got at an antique store, and it's also probably at least 100 years old. And removing like as much lignin as possible to kind of like reduce the hemp to like pure cellulose, like shorter fibers that look. But I'd also like to see the other infrastructure make its way back over here, because we don't have wet spinning like in the entire Western Hemisphere at the moment, which is just a huge loss of industry and manufacturing in our places, specifically like our rural areas. After all that, we went from stalks to long fiber.
All right, you guys. So here's just one more short video where we can all watch those steps one more time because repetition is key. I want you all to take note of not so much the tools, but instead the mechanical action being enacted on the fiber as it is transformed into usable material. Essentially, the stalks have to be crunched, beat, and combed, and how we arrive there has changed over time. And you can see all of the hurd still stuck onto the bast fiber, but it's very much fiber at this stage, no longer stalks. And this work is also very dusty, so don't do it without a mask. Okay, so now you've all learned primary processing. And this is, of course, the traditional way. So you can all say that you're classically trained on hemp processing. But what I'm hoping you gleaned from those two videos is a comprehensive picture of what the material must undergo in order to become line fiber or hurd. The tools themselves are less important, but they are the genius from which all of our modern bast fiber processing was birthed. And I'll also just mention that all of those tools were made for flax. So this is why there's so much overlap in the hemp and flax worlds. But also important to note is this is all you need to do to turn hemp stalks into spinnable fiber. At this point, after hackling, the fiber is ready to be turned into yarn. But as was previously mentioned, we do not have those kinds of spinning mills. Those would be wet spinning mills that can process long line fiber of either flax or hemp or any other bast fiber. So in the US, our work is not yet done. We have to do a few more steps to get to be able to spin. Okay, so now we're going to talk about some of the evolutions that we have available to us. The modern day break is called a decorticator. And on the right side, we have 3 examples of small scale decorticators. Okay, so the first one that we're going to talk about is this one. This decorticator was built by our farmer, Roger, at the Border View Research Farm, and he based it on plans he got from China, I think. And you can see on the left that on the inside, it's 2 fluted rollers, and it kind of looks like a mailbox or a very angry mailbox. Um, and one more thing I'll mention is I'll just let the video run first. So it looks tame here, but this machine is actually quite dangerous. A decorticator is basically the thing that your mom would tell you never to stick anything in or put your fingers near because it will pull you inside. Hence the tiny slot for putting stocks in. And for this reason, you can really only run one stock at a time on this one. And on the right side, you can see fiber that is under this decorticator. And we notice that it's green. So here's the thing. You can decorticate fiber green and it can come out very clean. And in fact, Steve from a few modules ago shared with us ever so briefly that this is something he's working on. But the kicker is you have to do it right away. If you wait even 4 to 5 hours after the fiber has been cut, it starts to harden and dry and you won't be able to decorticate it without retting. So you can decorticate green, but it basically has to be done in the field. And here are a couple more decorticators. On the left, we have the Fiber Track 118 by Formation Ag. And on the right, we have a newer one by Bish Enterprises. These are both American companies. The Formation Ag decorticator shown here belongs to UVM. And boy, if I thought Rogers decorticator was dangerous, I had only not met this one yet. Um, so we'll just watch that for a second. Okay. And the Bish one on the right has a bunch more safety features. It also feeds the fiber. It also feeds the fiber through at a slower and more controlled pace, which is good if we're trying to maintain fiber quality. Um, I wouldn't say that these machines are ideal for running lined fiber textiles. I just don't know of anyone who would use this system for that, but they do a good job for other end use applications, perhaps such as non-wovens or definitely herd material applications. And those are probably the smallest decorticators out there, but they do get much bigger. This decortication line is designed to run 1 ton of material per hour. A round bale is fed directly into it. And Cornell actually has one of these. So if Jacob or any of the Cornell folks are on the call, they can feel free to chime in when we get to Q&A if we have any decorticator specific questions. And I just included the second photo on the right to give you an idea of what a machine like this is designed to do. So it reaches 4 different value streams at one time. You can see there are 3 different sizes of herd, which it filters and separates out. And all 3 of those would have different uses, different end uses. And it also makes clean fiber. So I'm not exactly sure what this grade of fiber would be ideal for, but maybe once again, non-wovens, or if anyone has any ideas, throw them in the chat. Okay, so moving on to hackle versus hackler. This is a very exciting slide because last spring we at UVM Extension received the first mechanized hackler in all of the United States. We funded this through the USDA Sun grant, and this one came to us from Taproot Fiber Lab in Nova Scotia. So hackles are essentially combs that vary in fineness, comb out the fiber and separate its line into constituents. And you would only need to hackle fiber if your end use was line fiber. So again, this is a piece of equipment that is unique to line fiber production. And this one was also primarily designed for running flax.
Hey Laura, I think that
And
your
yes,
audio is breaking up a little bit. I think if you turn your camera off, that might make it a little bit better. I think it's just our Wi-Fi. It might be
okay,
slowing down a little bit. So if you don't have your camera on, it might be able to load it in better.
gotcha.
You're saying great stuff, so I want to hear it.
Uh,
I think that may help.
okay,
All right. Hopefully
there we
that'll
go.
help.
Thank you.
Everyone let us know if it
Okay,
clears up for you.
so this is our hackler. We call her Rapunzel for obvious reasons. And there was a time when I was working in here all the time and I started to dress like her. And then this is a quick little 13-second look at how she works. Okay, so we're going to come back to the hackler in just a minute. But first I want to tell you all a story. So in 2025, we created the first all local commercially spun and knit hemp garment in the Northeast. And in fact, we produced 3 of them. These garments featured our 70-30 and 60-40 wool hemp blended yarns. The wool was sourced from the Finger Lakes region of New York, and the hemp came from our research farm. The yarn was blended and spun at Bat and Kill in Greenwich, New York, and then knit at Muriel's of Vermont in North Hero. Okay, so that was an overview, but we got grant funding to work with a local business partner, in our case, local to us across the lake in New York, to make 6 blended yarns, which are pictured in the top right. And maybe you noticed there are actually 7 there, and it's true, we made 7, but the first was just a test run to prove to ourselves that we could do it despite all of the gaps in the supply chain. And when we embarked on this grant, we wanted to know how to grow and process fiber that would be permissible to our stakeholders, in this case, a spinning mill. In other words, what are they looking for in a fiber? Okay, so now maybe you're wondering what were the 6 treatments that made the yarn different? And that's the coolest part. Some of them involved field-retted hemp, some used winter-retted hemp, and we also ran material that retted for different durations of each of those. So we got to compare retting type and also retting duration in a finished good. And we also looked at different ratios of hemp to wool. And we ended the experiment with a 30-70, a 40-60, and also an 80-20 wool to hemp blend. So all of those had less percentages of hemp, just to be clear. And we learned so much by doing this. First and foremost, that it is possible at all. And now let's get into it step by step. In the next video, we'll look at some of the very same fiber that was used in the making of the sweater vests, and we will see how primary processing or scutching and secondary processing or woolenizing come together to make fiber suitable for our existing domestic markets. And Shannon's going to play the video for us in just a second.
Good morning, it's Earth Day, April 22nd, and today we are going to be processing some of our winter-retted fiber for woolenizing so that it can be blended with wool at Bat and Kill Fibers in Greenwich, New York. So this right here is the fiber we'll be working on. This is winter-retted hemp that was harvested just last week on April 15th. And it was planted in May 20th, so it was almost out there for a full year. We just harvested it, and we're eager to see what it looks like processed. And this will be a 2-step process. First, the fiber will be hackled on the hackler, and then carded with a little hand crank carder, and the end result will look something like this. So let's see what it looks like. So I just put the fiber in the clamp. The clamp rides a track through the hackler. I've left a bunch hanging over the top because we want to be more considerate of how far it's hanging down. If the fiber is hanging down too much, it'll have a tendency to wrap up in the machine, which becomes an hours-long problem. So we just like to avoid that. And I also like to avoid putting too many more cuts in the fiber at this stage because you'll get the most use out of the hackler with long fibers. So I just leave this kind of margin hanging over the top, which is just fine. And this fiber has actually already been cut in half once. So these stalks were twice as long as this. They were cut in half so that they could be dried in the dryers ahead of decortication. But otherwise they're basically fresh from the field, so they're about to go through the hackler, and we'll see them transform from plant material into true, like, raw usable material. That's scutching, so it's just removing any more of this hurd because that's really, like, not good for the hackler. The hackler is also built for flax, so it's not made for a material as sturdy as hemp, but we just want it as clean as possible going in. But there's barely any hurt on it, so it shouldn't be a huge problem. So I like to include, like, I can see there's a lot of like shorter fibers that aren't going to make it into this clamp, but it's sort of just creating like a line of best fit between getting the most fiber in the clamp and also hitting the correct length, because you'll notice like this much material doesn't get hackled underneath the clamp, so we need about like that much of a buffer from where the clamp goes. One has been run through the hackler twice on each side, and we're gonna call that done. It's looking very beautiful. So we've extracted the long fiber from the toe fiber for the most part. This would be the long fiber or the line fiber, and the toe is in that bin right over there. There's a really nice even color on it, which we don't see from the field retted fiber so much. Usually that's like a lot blotchier with dark spots, but this is nice and pretty even and consistent looking. So I'm just gonna twist this into a couple stricks, as they're known for storage at this time. And making a strick is much like making cordage. You have two strands that are being spun the same way, and then they're being twisted around each other in the opposite direction. And this is just a nice way to keep long fiber. And this would typically be spun, be wet spun at a long fiber spinning facility, but we don't have one of those, and actually the whole Western Hemisphere doesn't have one of those, so this will just be stored for now. This could make really luxurious textiles, linens, clothing, but it's also ideal for composites. For making composites, you want clean, meaning herd-free long fiber, so this is pretty much as ideal as it gets for that application. What we have here is kind of two separated grades of fiber from that one original pile that went through the hackler. This is everything that managed to stay in the clamp across the 4 runs through the machine, and then this is everything that fell down below. So what I'm going to do with this next is actually comb some of it out with the hand hackle and run it through again to just extract the longest fibers and make a few more line fiber stricks. And then the rest of the toe, the shorter fibers, about like this long and shorter, will be carded for woolenizing to be blended with wool and made into yarn. So these are all of the stricks of line fiber that I was able to extract from this last sample. And here is the toe, and I already weighed it, and it's just around 5 pounds, and there'll definitely be some loss over the carding process, but our goal for woolenized fiber is 5 pounds. So we're going to avoid cutting these up and woolenizing them as much as we can to meet the minimum we need to, and this is what we'll be running through the carder to woolenize. So I'm not sure if it's visually evident, but this one has been run through the carder once, this one has been run through the carder twice, and you can see the fiber is a bit more short and chopped up in the second pass. Yeah, you can see some of the more like these rustic, thick cut hemp fibers in the one that's only gone through once versus there's less of them here. So the final step is cutting the fiber to 6-inch lengths for the woolenization process, because the wool that this fiber will be blended with is max like 6 inches, so we need to make something that's similar. So this is our woolenized hemp, and this will be sent off for blending with wool.
Okay, so just remembering how much work all that was, Shannon, I'm thinking of you because you were a part of it. We just saw a pretty good synopsis in the video there, but I also want to give you some notes on woolenization. So cottonization and woolenization are the same thing. It just depends on what fiber you're blending with. In the US, we currently do not have the spinning infrastructure to commercially produce 100% hemp yarn. Therefore, in order to produce US grown hemp textiles in the US, we must blend with cotton or wool. Why? Because this is the domestic spinning infrastructure that we do have: cotton mills and woolen mills. This process can be done mechanically or chemically, but the main idea is to process the fiber into smaller and finer pieces. You have heard of processed food, and this is processed fiber. Dramatically reducing the staple length of the fiber is necessary to suit the pre-existing machinery. The overall quality of the textile will differ from that of line fiber textiles. And those steps, really quick for me in my process, involved cutting the fiber to 6-inch lengths and then carding it 3 times over. So in the end, we had the cottonized fiber or woolenized, which ended its primary processing journey looking like the line fiber on the right. And also remember that cottonized fiber is combined line and toe. It is one value stream for all bast fiber. And one very last picture of what the fiber looked like before I handed it off for spinning. And it's in 6 different bags because, again, we had 6 different treatments and made 6 different yarns. And in a minute, we will let our special guests take it from there. So joining us today, we have Tim Holt of Bat and Kill Fibers. Tim is a miller and co-owner at Bat and Kill Fibers carding and spinning mill. He has extensive experience milling wool and has taken a vested interest in bast fibers in more recent years. He also keeps sheep at his home in New York State. And our other guest is Cyrus Brooks of Muriel's of Vermont. Cyrus is a designer with Muriel's of Vermont knitwear brand. He designs the garments on a computer and then programs his Shima Seiki whole garment knitting machines, which knit entire garments in one piece. The process eliminates the need to link or sew, which reduces the labor required and virtually eliminates waste. Garments are also knit on demand, which minimizes excess inventory. And now we'll hear from both of them.
Hi, Laura. Thank you so much for having me. I'm not sure, is Tim on this call as well?
I'm not sure, Cyrus, but we're going to play the recording first and then do the Q&A.
Oh, okay, thank you so much.
All right, so we're so lucky to be joined by Tim Holt and Cyrus Brooks, who were our regional collaborators on our sweater vest project. How are you both doing today?
Good, thanks.
Good, thank you.
Great. So we just walked through all the steps that I performed in that process, and now I'm gonna hand it over to Tim to pick up where we left off. So Tim, can you please walk us through step by step your process at Bat and Kill Fibers from receiving the fiber from me to creating 6 batches of different blended yarns?
The first part of it really is, aside from discussing what kind of percentages that you want in your final yarn and what size yarn you want, which depends on where it's going. So in your case, it was going for knitting machines. And so that puts it into like the 1900 to 2000 yards per pound category, which would be kind of the upper end of a fingering weight and a 2-ply. Yeah, you had a 2-ply. And so now with the hemp, what we found, and there was a lot of learning that went on during this, is that first off, you want to start combining the wool and the hemp right off the bat. Because what is one of the key things in the carding process and pin drafting is that you don't want to have a section come through that is primarily hemp. You want every bit of the hemp to be distributed with the wool. And so picking, it does a good job of mixing, but it does not blend. And so what I ended up coming up with is I would put basically on the feed belt for the picker, you would put down a layer of hemp, and then you put a layer of wool on top of it. And then you run that through into the picker closet. And then once it's in the picker closet, you're going to do some manual mixing with the shovel or whatever. And then, just trying to distribute it really well. And so what was key with the hemp as a fiber for carding well in our worsted system is the primary processing, which was what you did on a Louette hand card, I believe,
Yes,
a drum. Um,
yes.
so you want, although the carder takes 6 to 8 inches max fiber length, and hemp grows naturally way longer than that, you cut it down. What is key is that there isn't a lot of toe, and toe just being short fibers as opposed to long fibers. But in hand processed hemp, those shorter toe fibers really make a big impact on how well it cards. And but that being what it is, you put it together and then it goes through the carder and then you get a roving. And then from there, and the percentages we ended up doing, we attempted 60-40, but that was a little bit too much hemp yeah, for hand processed hemp. And we ended up with 70-30, which was, to be honest, is still a little difficult, and better processing, primary processing will make that. There's room for improvement there, and you'll be able to get higher hemp percentages yarn with that. And I've done it, so I know that that is the case. And so 70-30. So what you're making is 70% wool, and it's white wool. But even just 30% hemp imparts a significant hemp quality to the product. There's no question that this has got hemp in it. So why I bring that up is because most of the time when somebody's goal is hemp or alpaca or mohair or whatever their fiber is, they would really like it to be 100% their fiber. And we would love to do that. But in this system that is really based on sheep's wool, it just won't work. So you can have quite a bit of sheep's wool in there, and you will still have something that definitely, shows that other fiber. So when you look at the numbers, you're thinking, well, it's 70% wool, so it's going to just seem like wool, but it doesn't. So then after that, from carding, it goes through pin drafting, which transforms it from roving into a sliver. And then the sliver then goes out to spinning, and then it is spun into a single, and then we bring it to and then we steam it. And the other thing that we learned about hemp is that it absorbs and holds moisture quite a bit better than um, wool. And so what was really critical to it working well and plying was that you gave it a lot of time to dry after the first steam. And that made a big difference. And so then you could, we applied it, and then after applying it gets another steam to set that twist. And then after that, it goes to cone winding or skein winding. And in your case, it was all cones. And so
Cool.
that's pretty much just the whole process.
So are you saying that hemp is more absorbent than wool?
Yes, I believe that is true.
All right, that's fascinating. Okay, well, thank you for that synopsis. So, at that point, we had completed what we had set out to do in our grant deliverables, which was produce yarn. And we were then confronted with these 6 different hemp wool blends that Tim crafted for us. And we had to figure out how to compare them with one another. And we could have just finished the project right there, but it just so happened that I was passing by Muriel's of Vermont every day on my commute from the farm to my home. So we really couldn't resist taking the research one step further. And Cyrus, can you share about your process from there, going with the yarns that we developed with Bat and Kill and turning them into garments?
Uh, yeah, well, our process for your yarn in particular, I took, well, so we sent it through a waxer first, real quick, and it puts a thin layer of wax on the outside of yarn. It also gets rid of a bit of the extra debris. And I do this with all yarn, wool, wool hemp blends, wool alpaca blends. It just really helps unify things for the knitting machines. But after that, I took a minute to calibrate my knitting machine for a new type of yarn. And that process is just making sure that the tension is appropriate for different stitch lengths. It also gives me a good idea of if it will work or won't work. And I felt pretty confident that we would be able to get a garment out of it. So I really just made what was a pre-existing hemp wool blend vest style that we've worked on for a while with hemp wool blend that we get from Bat and Kill, and I made it in the locally grown hemp wool blend, and yeah, that's pretty much it. Yeah, and
Awesome.
there it is.
I just want to take a moment to emphasize that these were the first all local commercially produced hemp garments in the Northeast in modern times that we know of. So we're very, very proud of them. Um, Tim, can you fill us in on some of the risks of running hemp on a wool mill, as in how flexible are these systems when it comes to innovating with different fiber? And what were like the trickiest moments? You mentioned the blend is really crucial, the blending part, so that the fibers are really integrated. Were there any other like obstacles that you overcame and learned from in this process?
Well, yeah, what was surprising to us is with everything we've ever worked with before, if it gets all the way through spinning, at that point, the only thing left is plying. And plying is usually, sometimes there can be a little bit of a problem, depending on the fiber. But most of the time, after spinning, you're kind of done with having problems, and plying just goes and you just finish it. But hemp was not like that. You would, in fact, the spinning was, the spinning may have been average difficulty. But then it got to plying, it was actually more difficult in plying. And the reason came down to really is that hemp has little tiny bits sticking out at different angles from the yarn. And what happens is when you get to plying, it's been spun onto a spool and then it's drawn off the spool, comes straight off the end of it. And so the yarn that's being drawn off is actually dragging across the rest of it that is not being unwound yet. And so if it's got little bits and pieces that are sticking out at right angles, they grab on those little bits, and then it it can drag for a second, it can put tension on it, and if it has a thin spot in it, then it will break. And so we ended up with a lot of broken ends on plying because of that. And so what we found is if we took it first and we put it through, we have a cone winder that has basically it's like a shaver. It just it passes through these two plates on either side of it that will knock off those kinds of little bits sticking out. And you can have this happen with wool yarns if the sheep's wool had a whole bunch of hay in it. Because, on the farm, it was, the way they fed it, they ended up with a bunch of vegetable matter in there. So we have seen it before, but with hemp, it is vegetable matter, almost the entire thing. So we had to figure out how to shave the yarn first, or rather that we should do that with it. And then the other thing we figured out is we ended up coming up with a different device to put two threads through the cone winder shaper first to put it onto a cone so that when it went on the plier, you had two threads side by side instead of just singles coming together. And that gave it more strength and, prevented it from breaking. Plus, what I already mentioned, the letting, giving it a lot of time to dry. So, and that's a bast fiber versus wool animal fibers, so we learned that. So all of that though, like what to do about that. We figured out what to do with it after we've got it, but really thorough or better. I don't know the primary processing of hemp. Like I've never, hand combed or hackled or scotched hemp or flax at all. So I don't really know what I'm talking about here, except that the stuff I've gotten that is more thoroughly done, we don't have those problems, and it just runs like regular yarn. Uh, yeah, that's really the whole difference. In fact, I'm thinking about, what is the primary barrier to being able to incorporate locally grown bast fibers into our fiber repertoire, and it really is just the primary processing. If we can get that ironed out in small scale, so we don't have to send it to someplace like Bassport down in Alabama where they do huge quantities, then we would be able to do this, grow it locally, and make stuff, just like yours, easily.
Okay, so when you're receiving a batch of hemp, because I know you've run research and development on this with a few different folks at this point,
Yeah.
what are you saying are like the most important characteristics that you look for when it comes to like the cleanliness of the fiber, so that vegetable matter you're talking about, like the tensile strength, the fineness, and the staple length? Like how would you rate those characteristics, and are there any other ones that you're looking for when you're working with a batch of hemp to run?
Staple length and fineness are the ones that I would care about. Vegetable matter, the whole thing is vegetable matter. So, that doesn't matter really with this stuff. And that kind of stuff tends to fall out in
Okay, like
along.
if there were herd materials and stuff in there, it's not a huge problem.
If it's actually separate from the fibers, then yeah, that'll fall out. That'll fall out of the off the bottom of the carder to begin with. Um, and we didn't really have too much trouble with him staying behind in the carder, and being in there for the next job to pick up. There's a little bit of that, because we have to think about what's coming next.
Hmm.
And herd is something that would be more likely to stay in the carder, and then we'd have to deal with that for the next job. So we'd have to make sure we did something, clean the carder, run some fiber through it that's going to pull that stuff out. So I guess cleanliness to a degree, it's at the bottom of the list though, because
Okay.
it does really just kind of fall out. And there's, with wool jobs, animal fibers, there's all kinds of stuff in there, and that falls out as well. That's not new.
Hmm.
Um, yeah, but fineness of the primary processing and staple length, those are
Okay.
the key.
Good to know. Cyrus, can you likewise tell us some of the risks that might arise when running atypical yarns in your system? And how do you judge if a yarn was successful or unsuccessful in that process?
Um, yeah, honestly, like Tim said, a lot of it is uh, skewing vegetable matter that will come like jut out at kind of awkward angles. Or start to, because as I run things through the machine, the yarn will rub up against certain parts of the machine, and that'll create like a debris spray of matter. And the more kind of loose matter that there is in a yarn, the more it'll kind of gunk up my machine and slow things down. On top of that, I would say actually something that's big for me as well, is consistency in gauge. Just here and there, some yarns that I receive, and this goes for any, well, it goes for any type of spinning and it goes for any type of yarn. I sometimes will find like, I don't know if there's a technical term, but we call it slubbing.
Mhm.
Where it'll like change and gauge really quickly, and there'll be like a big chunk of ununiform yarn in what I'm working with, and that, like, there are several sensors on the machine that tends to stop those before they become a huge problem. But it does mean it like either has to get kind of pulled out, cut out, spliced back together, um, or if the sensors do miss them, which happens, it can cause a little more damage inside the machine where it won't, because it's bigger than the rest of the yarn that the machine's been working with, so the needles can't pull it down properly, and it can cause what we call a crash, which is just the machine crashing into itself, and some stuff can break, which happens. It's not uncommon, but it is nice to avoid. And yeah, and then so it happens with all kinds of yarns that I receive. It's just the more that it happens, the more time I have to take to kind of work the yarn through. That being said, I did not have many issues with any kind of slubbing or changes and gauges in the sample yarn that I tested for you guys, your wool hemp blend. But it was a lot more the first one where there was a lot of kind of debris matter that would come pulling off of the yarn when running through the machine. And like Tim said, the vegetable matter pointing out in different directions can also trip up those sensors, which is fine. I just kind of pluck it out, but it can get it can kind of add time to the process, and it also adds a level of routine cleaning that would have to happen to the machine. So, yeah.
Makes sense.
Yeah.
Okay, so this is a question for both of you. What have you noticed in your tenure as fiber processors about your customer base and consumer interest in plant-based yarns? Have you noticed enthusiasm from both customers and other interested parties change over in recent years?
Who's going first?
You can go first, Tim.
Okay.
I like adding to what you say.
So, um, one of the things I found with hemp blends is, first off, Most of our business is oriented and has been for a very long time towards knitters. And so knitters, when they're shopping for a yarn, if they're considering a yarn, generally what they do is they pick it up and they feel it. And and then is it soft? Is it got whatever the quality it is, and whatever the qualities that yarn has at that moment are that's at its peak. It's as nice as it's going to be, and they make whatever they're going to make, and then it ends up being nice because it was nice when they bought it, and then it wears and goes through its normal life cycle. With Bass Fibers, what you've got there is something that, although we process it a hell of a lot, it has like a new pair of boots it needs to wear in. So when you're looking at that thing at the point of sale, it it doesn't actually feel like what it's gonna feel like. So, and most, in knitters, that's not how it's always been. And so there's that kind of barrier to acceptance. So that's, like an educational kind of thing. Or one way or another, that's what that is. But then the other thing we found though, where it does seem to work really well, is weaving. It's better suited to weaving, and it makes really great like outer kind of things for like a coat shell, or for upholstery, for homewares. It can make really great stuff. We've made placemats, table runners. Lily Marsh has made cloth that she uses for different things. And this stuff, well, it can be extremely rough if you want it to be, but it doesn't have to be. So it really works well for that. And generally, I would say it works well for making cloth. It can work very well for knitters too, but they need to understand that it's going to change after
Right.
you start using it.
That's really fascinating because I hadn't thought about that, but I can also attest to the hemp textiles change over time dramatically.
We
And Cyrus,
actually, well, so we, just to add to that, um, for 90% of our garments, we soak them in a botanical conditioner and vinegar soak, and run them through a drying process, which is, I can like to look at it as kind of that first step of breaking in the new pair of boots, where you kind of move it around in the dryer, and then those fibers will soften up a little bit. And after the botanical conditioner and vinegar, they soften up as well. And then the dryer will kind of, it'll work the yarn a little bit, and it'll also shrink it down to size. And so it makes it a much more wearable garment, after we do that first step in our process as well. Or I guess the last step in our process. Um, but in terms of, I guess, like, the receptiveness, was that kind of the original question of
yeah, just consumer interest in bass fiber text garments and textiles.
yeah, well, so it's interesting for us because I think that our customer base is actually a pretty broad spectrum. Of some people find us looking for um intentionally produced local high fashion garments, and those people aren't always the best sell on a wool hemp blend. And things like the wool alpaca blends tend to be a little more up their alley when you're looking for something in the more luxury world of high fashion. But I think that those people tend to be really surprised with how soft our wool hemp blends are, and how those vests actually make a great kind of piece to add to a wardrobe that is pretty versatile and pretty flattering. I think that then on the other end of the spectrum of our customers, there are people who could not be more enthused about local garment production, whatever that looks like, right? And if they were to know that the hemp in the sweater was local, as well as the processing, as well as the production. It's a huge, huge selling point for them, and something that we feel very proud of that we can be a part of. So, I think that there is a big excitement in the potential for that.
That's awesome. I'm going to cut you off because we're about to run out of time, but thank you, Cyrus and Tim, so much for your input here, and we look forward to having you on the Q&A. Hey guys, so I'm just going to keep my camera off because we were saying we had some sound issues, but we're so lucky to be joined by Tim and Cyrus, and I'll just get right into questions. This one I'm going to direct at Tim because we have some people asking about have you done any experimenting with using either lanolin or like a flaxseed goo to smooth the yarns? I think for the same utilized for the same reasons, which would reduce fibers poking out at weird angles. And Tim, I know you have done a lot of research on flax, so I'm just wondering if you have any insight on those, lanolin or boiled seeds.
So the only time we would add anything like that would be at the very end when it was already spun and plied. Putting anything sticky or gooey into any of our machines is not a good idea at all. But we do the wax at the very end. You can take it from the bobbins and put it to the cone and give it the light wax coat, like Cyrus was talking about in here just earlier. And that does knock that kind of stuff down, but it's literally the last process before it leaves us and would go to someone like a machine knitter or a weaver.
Great, thank you. Can you share what kind of carding equipment you use at Bat and Kill?
We have a very old Davis and Ferber card. That's the basic, part of it. It's for worsted. I'm not sure what other details someone might want, but it's very large.
um, that's probably good. Just looking for someone asked about sharing the commercial decorticating machines. We've included the links to all the companies that were mentioned in your resources. I see Terry also put his number in there if anyone's looking for equipment from China. And I'll turn my camera on again so you guys can just all see the beautiful vest we made.
Nice.
Yes. Please put your questions in the chat, y'all. We have time for maybe one or two more. So in theory, could a wet spinning mill meet the needs for both flax and hemp, or are they more specialized? Um, I think that the answer is yes. Tim, what do you think?
So I don't have any direct experience with wet spinning myself, but if you're going to go to very fine stuff, wet spinning, the point of it is it wets the fibers down and lets it allows you to draft it finer without it actually breaking. And yeah, again, this is speculation on my part, but I would think that it would probably work with both fibers, both flax and hemp.
Right. So it's hemp that's going to be grown in a very specific way that almost mimics flax because you're doing that really high seeding rate. The plants will be shorter, and you're going to harvest them really early. So they'll be nice and tender because hemp is a lot hardier than flax, but they are the same process. And I think that they would be the same mill. I don't know of I'm sure these mills exist in Europe, and I wonder if they ever run the other, like both materials. So I think I think the answer is yes, but I can't definitively tell you. Um, okay. And someone asked to explain wet spinning, so that was a pretty good synopsis. long fibers are wet spun. Wet spinning facilities are also going to need a specific humidity. Is that true of wool spinning mills as well?
Yeah, humidity makes a huge difference in how fibers behave.
Right. So there's a lot of nuance um, in spinning, and spinning is our major bottleneck here in terms of bast fibers. But you can see that anything is possible if you're willing to card it for maybe 80 hours. I don't know.
No, it's not at all like
um, okay, what has to happen in the Northeast fiber system for these wool hemp garments to be available to the average consumer at an affordable price? Oh no. That still enables the equitable distribution of value at every step in the chain. Or do things truly need to be priced at $250 a garment? So I'm just going to handle the very last sentence first by telling you guys a story that was told to me by Robin Maynard Seaver, who has a company called Green Mountain Linen. And she's in a little town somewhere, East Barnard. And she had a story about someone from the 1800s who was from East Barnard, a woman who was paid, she was commissioned to make 2 linen shirts, and she was paid 5 acres of land for that. So I think we all need to consider like the true cost of garments and all that goes into them, and and maybe ponder what prices are appropriate for clothing, because we all live in this kind of upside down world where we have fast fashion, which costs very little because people aren't getting paid for that labor. So just a little bit of perspective on how much work goes into clothing, and what things should or could or can cost. And I'm just gonna show you guys, we'll just do our recap real quick. So to recap, the 4th module, primary processing of hemp fiber consists of breaking, scutching, and hackling. At this point, it is ready for hand spinning or wet spinning, but in the US, fiber must be processed further, either woolenized or cottonized, before it can be commercially blended and spun. Spinning yarn is our domestic barrier, but once we have yarn, we can make almost any woven or knit soft goods. And identifying and meeting the needs of our pre-existing industries is one way to see hemp happen. And if my PowerPoint responds, I just want to give a big thank you to Heather, Roger, and all of our team for making all of this research possible. And that's it, you guys. Go forth and grow hemp. And if you want the CCA credits, you can scan the code here. So thanks so much for joining. Thanks to everybody who is in it for all 4 modules. Thanks to Shannon for putting it on, and Tim and Cyrus for joining us.
Sure.
Really great.
Thanks, everyone. We'll make sure that this recording is available, and make sure to share the course with everyone everyone you know, everyone you work with, and
Tell
anyone can enroll.
everyone.
Everyone. Anyone can enroll in the Extension Foundation campus course portal, and you guys can always access the recordings there as well. So if you didn't end up enrolling, you can
Bye,
still
guys.
enroll. Bye. Thank
Bye.
you.
Bye.